March 1st, 1982. A photograph is forming, line by line, on a screen in the Soviet Union. It is the surface of another planet. Grey rock and dark soil scattered out to a flat horizon. It is coming from a place where, until a few hours ago, nothing made by human hands had ever survived long enough to take a picture. The machine sending it home is already dying in the heat. For 30 years, almost no one looks at this image closely. Then one man does. His name is Leonid Ksanfomality, a senior Soviet scientist, one of the people who helped build the very missions that took these pictures. He is doing something nobody bothered to do before. He lays the original frames side by side, in order, and asks one simple question: does anything move? In the soil, off to one side of the lander, there is a shape. In an early frame, it is not there. Then there is a shallow groove in the dirt. Then part of a structure. Then, about an hour and a half after landing, the shape is fully there, roughly the size of a hand. He keeps going. A few frames later, it is gone. He checks everything. The lander has not broken. Nothing has fallen off it. And whatever this is, it appeared, it changed, and then it vanished. On the surface of a planet hot enough to melt lead, so he publishes what he sees. The response is immediate. He is told, in so many words, that there is nothing there. Move along. The photographs slide back into the archive. The question goes quiet, but it never closes. It only gets buried. And the closer anyone looks at these old Soviet frames, and at the planet they came from, the harder it becomes to say there was nothing there at all. The planet is Venus. And by every measurement we have, it is the most hostile place that human machines have ever touched and lived to report back from. Start with the air. The atmosphere of Venus is almost entirely carbon dioxide, about 96 parts in 100, with a small amount of nitrogen and very little else. It is the densest atmosphere of any rocky planet in our solar system. Now stand on the surface and feel its weight. The pressure at the bottom of that atmosphere is roughly 90 times what you feel at sea level on Earth. To find a comparable crush on our own planet, you would have to descend into the ocean to a depth of nearly a kilometer down, where sunlight no longer reaches, where the water itself becomes a wall. Except on Venus, this is not water. This is air, pressing down on solid ground. Then there is the heat. The average surface temperature on Venus is around 460 degrees Celsius, hot enough to melt lead. And it barely changes, not between the long Venusian day and night, not across the seasons, not from the equator to the poles. The whole planet sits at a steady, furnace-like temperature, top to bottom. Above all of this hangs a permanent ceiling of cloud, thick, opaque, and made not of water, but of droplets of sulfuric acid. Those clouds are so complete that from space, in ordinary visible light, you cannot see the surface at all. The planet keeps its face hidden. So here is the problem the Soviet Union set itself. To land a working machine on Venus, you have to build something that can fall through clouds of acid, withstand crushing pressure, and keep its electronics alive in heat that would destroy almost any material we know long enough to do science and send the results home. It sounds impossible. They did it anyway, again and again. Beginning with a probe called Venera 8 inches 1972, the Soviet Union landed on the surface of Venus 9 separate times. Not flew past, not orbited, landed, and transmitted from the ground. In most of those missions, the lander was still working and still talking when its companion spacecraft, the orbiter relaying its signal, passed out of range overhead. The machines on the ground often outlasted the window they were given to speak through. And the Soviets did not only land. After the surface landers came 2 more probes, in 1985, that did something stranger still. They released balloons into the atmosphere of Venus on the planet's night side and let them float downward through the clouds for nearly 2 days, drifting instruments suspended in an alien sky, measuring the air as they fell. And here is something worth holding on to. Those Soviet landings remain, to this day, the only direct ground truth we have from the surface of Venus. Every map drawn from orbit, every observation made from a telescope on Earth, every model of what that surface is really like, all of it is still anchored to data. The Soviets gathered in the 1970s and early 80s. We have not been back to the surface since. That is the strange weight that sits on these old photographs. They are not just historical curiosities. For half a century, they have been the closest thing we have to standing on Venus ourselves. Which brings us to one man, the person whose name sits at the center of this entire story. His name is Leonid Ksanfomality, and by the time he became famous for the wrong reasons, he was already one of the most respected planetary scientists Russia had ever produced. He graduated from the Leningrad Technical University in the mid-1950s. He worked at an observatory. Then, in 1968, he joined the Space Research Institute, where he eventually became head of a laboratory studying the light and heat that planets give off. He was not a man on the fringe. He was, as one writer later put it, a senior statesman of his field, a scientist, an engineer, and a popularizer who spent decades bringing space science to ordinary people. His instruments flew on mission after mission. He designed sensors for the Soviet Mars probes. He worked on the analysis of Venus's clouds during earlier Venera flights, and he built a set of instruments called GROZA that flew on several Venera landers. That detail matters, because those GROZA sensors were the first devices ever to detect intense lightning storms in the atmosphere of Venus. Sit with that for a moment. Long before any of this became controversial, this was a man who had pointed an instrument at Venus and discovered something real. Something confirmed that the acid clouds of that planet crackle with lightning. So when, decades later, the same man looked again at the old Venera photographs and announced that he saw something moving in them, the scientific community could not simply wave him away as a crank. He had earned the right to be taken seriously. That is exactly what made what came next so difficult. To understand what he saw, you have to understand the machine that took the pictures. The story centers on a single spacecraft, Venera 13. It was built, together with an identical twin called Venera 14, to take advantage of a launch window in 1981. The two probes left Earth just 5 days apart. Venera 13 launched on the 30th of October, 1981. Then it spent about 4 months crossing the gulf between the planets. On the 1st of March, 1982, the descent module separated from the part of the spacecraft that had carried it across space, and it began to fall toward the surface of Venus. Now think about what that fall actually involved. The lander plunged into the atmosphere and deployed a parachute. But Venus is not Earth. That dense, heavy air does the work of slowing a falling object so effectively that, at a certain point, the parachute is no longer the right tool. So, at an altitude of around 50 kilometers above the ground, the parachute was cut away and the lander simply used the thick atmosphere itself as a brake for the rest of the way down. It touched the surface at roughly 7 to 8 meters per second, about the speed of a brisk fall. It came down just east of an elevated region of the planet known as Phoebe Regio, a landscape of bedrock outcrops surrounded by dark, fine-grained soil. And then it started to work. Here is the single most remarkable fact about Venera 13. Let it sit, because it is easy to read past and miss what it means. The lander was designed to survive on the surface of Venus for about 32 minutes. It survived for at least 127. Think about what that number represents. In an environment hot enough to melt metal, under pressure that would crush a submarine, a sealed Soviet machine kept its instruments alive and kept transmitting for more than 4 times longer than its own engineers believed it could. Every extra minute was a minute the designers had not promised. Every extra minute was a gift. How did it last that long? The lander was a hermetically sealed pressure vessel, and inside it, the engineers had packed blocks of a salt-like substance called lithium nitrate, a material chosen because it can absorb an enormous amount of heat as it melts. The heat of Venus poured in, the salt soaked it up, and for 127 minutes, the electronics inside stayed cool enough to function. It was busy while it lived. It carried a drill to take a sample of the surface, which it pulled into a sealed chamber kept at a controlled temperature and a fraction of the outside pressure, and then analyzed, identifying the ground as a dark volcanic rock, something broadly in the family of basalt. It carried instruments to measure the atmosphere, the light, the soil, and it carried microphones. There was even a quiet engineering refinement in how it arrived. The earlier landers in the program had relied on parachutes all the way down, and parachutes are delicate things, prone to failure. Venera 13 and its twin used a parachute only for the first part of the descent, then trusted the thick Venusian air itself to do the braking, a simpler approach with fewer ways to go wrong. Those microphones are why this story opens with a sound. Venera 13 made the first recording of sound ever captured on another planet. It picked up the Venusian wind. It picked up the thud of the lander striking the ground. It picked up the small, explosive pop of its own lens caps being blown off after landing, and it picked up the grinding of its own drill biting into the surface. It also carried 2 cameras, mounted to look out across the surface in different directions. They were named, simply, by their positions, one looking out one way, one looking out the other. The cameras had a problem. Their quartz windows were sealed under protective lens caps that were supposed to pop off automatically once the lander was safely down. For Venera 13, only one of those caps came off cleanly. Remember that detail. A single ejected lens cap, lying somewhere out there on the soil of Venus. It is going to matter a great deal. As the cameras swung back and forth, they built up panoramas of the landscape line by line, sweep by sweep. And the images that came home are the ones that, 3 decades later, a respected scientist would sit down and study one frame at a time. For most of those 30 years, when people looked at Venera images, they looked at a single picture from each landing site. But that single picture was a kind of illusion. The clean panoramas you have probably seen are not raw photographs. They are mosaics, composites, stitched together from the best parts of several separate scans. That is the detail that set everything in motion, because Ksanfomality realized that the individual scans, the ones nobody had bothered to lay side by side, had never really been compared against each other. So that is what he did. He took the separate frames from Venera 13 and lined them up in sequence. And he asked a simple, almost childish question. From one frame to the next, does anything change? What he reported finding is the heart of this entire story. According to Ksanfomality, several objects appeared in the images that ranged in size from about 1/10 of a meter up to 1/2 a meter. Objects with what he called unusual shapes. And the unusual thing was not just their shapes, it was that they did not stay still. They were present in some frames, absent in others, or they changed their form between one image and the next. He gave them names. One he called a disc, one he called a black rag, and one, the one that would make headlines around the world, he called a scorpion. Let us take the scorpion fully, because it is the clearest example of what he believed he was seeing. By his account, the object appeared on the camera looking out one side of the lander at around the 90th minute of the mission. Before it showed up, the lander had already been sitting and working on the surface for more than an hour and a half. That timing was the first thing that struck him. His initial assumption was the obvious one that this was simply a piece of the lander that had broken off, but he checked the records. The lander kept working for a full hour after the object appeared. If a real piece of the machine had shattered off, the lander should have failed soon after from the heat pouring into the breach. It did not fail. It kept reporting, healthy, for another 60 minutes. So Ksanfomality looked back through the earlier frames at that exact spot on the ground. and he described a sequence. At 7 minutes into the mission, there was a shallow, narrow groove in the soil where the landing had thrown dirt aside about 100 millimeters long. By 20 minutes, the sides of that groove had risen, and it had grown to about 150 millimeters. By the 59th minute, part of a regular, structured shape had begun to appear inside it, and by the 93rd minute, the full object had, in his words, recovered completely from the soil that had covered it, soil he estimated was only a centimeter or two deep. The whole emergence, from the first groove to the full shape, took about an hour and a half. Then, by the 119th minute, it was no longer visible. Now, here is the interpretation Ksanfomality offered, and it is important to be precise about what kind of claim this is. This was not a measurement, this was a hypothesis, his own proposed explanation for what he thought he was seeing. He suggested that the violent arrival of the lander, the explosive bolts firing, the drill grinding, the impact throwing soil a few centimeters deep might have buried something. He even speculated that on one side of the lander, anything living might have had time to move away from the danger, while on the other side, things were caught and covered by the ejected soil. And that the slow hour-and-a-half emergence of the Scorpion was something digging itself back out, slowly, because whatever it was had limited strength. That is a genuinely extraordinary thing for a serious scientist to write down. A structured object, emerging from the soil over 90 minutes, on the surface of a planet hot enough to melt lead, and then vanishing. He was careful to add one claim. He stated that no retouching and no adding of details had been applied to the images. That single sentence is where the trouble began. Before we get to the trouble, we have to slow down and understand the images themselves, because almost everything about this debate comes down to one question. What does it actually take to see anything at all on the surface of Venus? The answer is that it takes an enormous amount of work, and every step of that work introduces room for error. Start with the light. Venus is wrapped in that permanent shell of acid cloud. The sunlight that reaches the surface is dim, diffuse, and constantly shifting as clouds drift overhead far above. In two Venera 13 images taken about an hour apart, you can actually watch the quality of the light change, sometimes sharper, sometimes softer, almost certainly because the cloud cover overhead was moving, throwing vague patches of lighter and darker sky onto the ground below. So the lighting itself is unstable from frame to frame. That is the first complication. The second is the surface. A lander does not arrive gently. Venera 13 came down hard enough to disturb the ground, kicking up dust and soil that settled back onto its own flat surfaces and onto the area around it. Some of that loose material then blew away during the short time the lander was alive. Two images taken an hour apart show soil gradually being blown off the landing ring. The scene was changing not because anything was alive, but because the act of landing had stirred everything up and the wind was slowly tidying it. So the ground itself shifts from frame to frame. That is the second complication. And here is a deeper one that has nothing to do with Venus at all, and everything to do with how the pictures got home. The lander's images were sent up to the orbiter and relayed to Earth using two different methods of encoding the signal onto the spacecraft's radio carrier. One method and another, technically distinct. And those two methods produced two different kinds of noise in the final images. So if you take one Venera 13 panorama and compare it, pixel by pixel, against another version transmitted a little later, you do not get two identical pictures. You get two pictures that are fundamentally similar. Most of the detail lines up, but scattered through them is a haze of difference. Data dropping out here, values drifting there. Odd systematic variations in a few spots. Almost all of it is noise. Noise from the transmission, not from the planet. Now, pause here, because this is the moment the ending of this story quietly announces itself. Everything we have just described is about the surface, the crushing pressure, the lead-melting heat, the buried Scorpion, the disturbed soil. All of it lives down there, on the ground, where Venera 13 died after 127 minutes. But notice something. We have already said that the one part of Venus that is genuinely confirmed to be active, the lightning that Ksanfomality's own instruments first detected, does not happen on the surface at all. It happens far overhead, in the clouds. And those clouds, 50 kilometers up, are not 460 degrees. High in that acid haze, the temperature drops to something almost gentle about the warmth of a mild afternoon on Earth. Hold that thought. We will come back to it. For now, return to the ground and to the photographs, because the real argument is about what is actually in them. When you combine all of these things, the shifting light, the disturbed soil, the wind, and a thick layer of transmission noise that differs between versions of the same image, you arrive at a hard truth. It becomes genuinely hazardous to read too much into small changes in blurry shapes from one frame to the next. That is the precise spot where critics say the scorpion lives, not on Venus, in the noise. Ksanfomality did not describe only the scorpion. He described 3 strange objects, and the way the other 2 behave tells you a lot about how to read all of them. The second object was the one he called the black rag. In the images taken in the first 13 minutes after landing, he reported a vertically standing black shape, about 60 millimeters tall, of unknown origin, wrapped around one of the lander's measuring instruments, a cone used to test the mechanical properties of the soil. And then, in the 2 images that followed, taken at 27 and 36 minutes, the black rag was simply gone, vanished, without a trace. One new detail makes this one worth pausing on. Unlike the scorpion, which he placed out on the open ground, the black rag was clinging to the lander's own equipment and then disappeared within the first half hour, the exact window in which the disturbed dust from landing was still settling and blowing away. The third object he called the disk. And here we can be brief, because the disk is where his interpretation runs into its simplest and most damaging counter-explanation. The disk was a regular, rounded shape, about 1/3 of a meter across, cut off by the top edge of the frame so that only its lower half was visible. He reported that it shifted position slightly and changed form across the frames, at one point appearing to break into fragments, and then, in a later image, being replaced by a different bright, regularly shaped object made of angular folds, which he likened to chevrons. So one of his strongest pieces of evidence was a regular disc-shaped object that seemed to move from one place to another between images. Now, remember the detail we set aside earlier. Venera 13 had 2 lens caps that were supposed to pop off after landing. They were ejected onto the soil. Engineers familiar with the spacecraft offered a far more ordinary reading of the moving disk. It was not one object that had moved. It was the 2 ejected lens caps lying in 2 different places on the ground. 2 similar-looking, perfectly inanimate pieces of the lander, mistaken across frames for a single thing that had traveled. That is the pattern the skeptics see throughout. Not life. Hardware, dust, shifting light, and noise. And then there is the sentence. The one Ksanfomality wrote to defend his work, which ended up doing the most damage to it. He stated, firmly, that no retouching, no drawing in, and no manipulation using professional image editing software had been used on the pictures. But in the same work, he also described the processing he had in fact done. Missing pieces of images had been filled in using data from other images. Contrast and brightness had been adjusted. And most strangely of all, the blur and sharpen tools in a basic, standard piece of computer painting software had sometimes been applied. Those are not nothing. They are, every one of them, adjustments to the image. And sharpening, in particular, does something dangerous to a noisy picture. Push it too far, and it begins to invent edges that were never really there. It makes rocks ring with false outlines. It pulls hard shapes out of soft fog. So the man who insisted the images were untouched had, by his own account, sharpened them, brightened them, and patched them with pieces of other frames. When a science writer at a major space organization examined his published figures in early 2012, that was where she stopped. Her conclusion was blunt. With that much variation in the noise across the images, and that much sharpening and infilling on top of it, she argued there was simply no point in micro-analyzing tiny shapes to decide whether they had moved, let alone whether they were alive. In her view, there was nothing there. Move along. The story had reached the public through a sensational headline from a Russian news agency, Life spotted on Venus. The scientific reaction was swift and largely dismissive. A journal published commentaries pushing back. A popular science outlet refuted the claim. And Ksanfomality, undeterred, went on to publish a second article describing still more shapes he believed were living things around the landing site. The senior statesman of Russian planetary science had, in the eyes of much of his field, gone over an edge. But that is not quite where the story ends. Because someone went back years later and tried to settle the question properly with tools Ksanfomality never had. Here is what is genuinely fair about the Scorpion debate. For years, it was just eyes against eyes. Ksanfomality looked at the frames and saw something alive. Critics looked at the same frames and saw noise and lens caps. There was no neutral referee. So researchers eventually brought in referees that do not care about the answer software. In a study published more recently, the Scorpion, now simply called the Target, to strip away the loaded name, was put through 3 separate kinds of analysis. The first was detailed image analysis. Investigators isolated, cropped, and magnified pieces of the object and compared them, surface against surface, with the soil right next to it. They ran edge detection routines to trace the fine structure of both. The second was machine learning. The object is roughly 150 millimeters long and about 35 millimeters across at its widest. The researchers laid down small square sample patches along the object itself and more patches at random across the surrounding soil. Then they let a trained neural network, the kind of system used to recognize images, judge mathematically how similar the object was to its surroundings. The third was fractal analysis. This is a way of measuring how complex and how branching a structure is, how it fills space. The same kind of method had been used before on features photographed on Mars. Here, it was used to ask whether the object's complexity differed from the soil's and whether that complexity changed as the object appeared and then disappeared. So what did the referees say? The results were not as simple as either side wanted. On one hand, the analyses did find that the object stood out from its background. It looked more in focus than the surrounding soil. The fractal measurements found that it was slightly more complex and, notably, more uniform. It varied less than the random soil patches around it. And there was some evidence that this complexity rose when the object appeared and fell when it vanished. In other words, something measurable really did change at that spot, in step with the appearance and disappearance Ksanfomality had described. That is not nothing. It is enough to rule out one explanation, the idea that someone had simply pasted a fake object on top of the picture, or that the wind had blown a piece of debris into the frame. The analyses argued against both. But on the other hand, the same tools found deep similarities between the object and the dirt around it. The branching, tube-like structure on the surface of the object looked like the branching structure of the soil. In places, the structure of the object appeared to be continuous, with the soil flowing into it, not separate from it. The machine learning found only the faintest links between the object and its surroundings, but the visual anatomy told a story of an object made of the same stuff and partly merged with the ground it sat on. So the study reached a careful, deliberately hedged conclusion. On the balance of probability, it found the Scorpion is most likely entirely lifeless, and it appears lifelike because of the repeated, layered application of image processing to one particular patch of soil. Sharpen a noisy patch of ground again and again, and you can coax a shape out of it that looks, to a hopeful eye, like something with a head, a body, and limbs. And yet, and this is the part that keeps the door from fully closing, even that study would not slam it shut. Its authors were explicit that you cannot decide in advance what conditions life might exploit on a world with a history completely unlike Earth's. To assume Venus must be dead simply because it is hostile to us is its own kind of bias, what one scientist called terrestrial chauvinism. The probability, they judged, was overwhelmingly against the scorpion being alive, but probability is not certainty, and the honest answer remained, most likely not, but we cannot say never. That is where the scorpion rests today. Almost certainly a trick of dust, noise, and an old man's sharpening tools. Almost certainly. Not quite entirely. If that were the whole story, it would be a sad footnote, a great scientist, decades past his real discoveries, seeing faces in the clouds. But the question he was really asking never went away. It just moved. It moved upward, off the surface, into the sky. In 2020, an international team of astronomers announced something about Venus that had nothing to do with old Soviet photographs and everything to do with the same buried question. They had pointed telescopes at the planet, first a telescope in Hawaii in 2017. Then, to check the result, a far more sensitive array of antennas in the high desert of Chile in 2019. Both were observing Venus at a wavelength of about 1 millimeter far longer than the human eye can see, the kind of light only specialized telescopes at high altitude can catch. And in the clouds of Venus, both instruments found the faint fingerprint of a gas called phosphine. Now, the amount was tiny, on the order of 20 molecules in every billion, a whisper. But the reason that whisper mattered comes down to what phosphine is. On Earth, phosphine is what scientists call a biosignature, a gas that, on a rocky planet, is strongly associated with life. Here, it is produced industrially, or it is produced by microbes living in places without oxygen. Normal, lifeless chemistry on a rocky world makes almost none of it. That is exactly why researchers had spent years studying it as the kind of gas you might go looking for as a sign of life on planets around other stars. And here it was, apparently, on the planet next door. The team did the responsible thing. They went hunting for every ordinary, non-living way to make phosphine on Venus sunlight, driving chemistry, minerals blown up from the surface, volcanoes, lightning. And they found that all of those sources combined would produce at most a tiny fraction of what they were seeing. By their estimate, the known non-biological pathways fell short by a factor of around 10,000. So what could be making it? And there is one more thread worth pulling, because it loops back to those Soviet probes. When the second of the two balloon-carrying Vega missions sent an instrument down through the lower clouds, it reported high levels of a phosphorus-bearing substance in some of the cloud particles. Phosphorus, the very ingredient at the heart of phosphine. Unlike the clouds of Earth, the clouds of Venus appear to carry it. That does not explain the gas, but it means the raw material was there, in the haze, long before anyone went looking for the signal. This is the moment to be careful. And the scientists themselves were careful. A biosignature is not a body. The detection of a single suggestive gas does not mean life has been found. It means a question has been opened. And almost immediately, the question got harder. Because here is the strangest part of all. If there is life in the clouds of Venus, it is living in one of the most punishing places imaginable. The high clouds, around 50 kilometers up, are at a temperature that is almost pleasant, but they are made of roughly 90% sulfuric acid. On Earth, the toughest microbes we know can endure only a small fraction of that acidity. Anything floating in the clouds of Venus would have to be unlike anything in our experience. The doubts came quickly, as good science demands. Other teams reanalyzed the data. The signal was contested. Some argued it was the result of processing or statistical error, others that it was a different gas masquerading as phosphine. The team behind the original observation in Chile even found and corrected an issue in their own data and made it public so the whole community could test it. The debate has not been cleanly settled. A later observing campaign reported fresh evidence of phosphine in the clouds using different methods than the disputed ones. The argument continues. And this is exactly how it is supposed to go. To understand why the caution is not weakness but discipline, it helps to look at what has happened with claims like this before. In 2014, a team of highly respected cosmologists announced they had detected ripples from the earliest moments of the universe, a discovery that made headlines around the world. On closer study, the signal turned out to be misinterpreted light from dust in our own galaxy. The team withdrew the claim. And on Mars, the gas methane, another possible sign of life, was detected back in 2004, only for follow-up observations from later spacecraft to return contradictory, inconclusive results that scientists still argue about. That is the normal life of an extraordinary claim. It is announced, it is doubted, it is tested by people with no stake in the original answer, and it either survives or it does not. A single detection, however careful, is the beginning of the process, not the end of it. The phosphine on Venus is sitting, right now, in the middle of that process. And when scientists sat down to write the definitive review of where this gas could possibly come from, they reached a conclusion that should sound eerily familiar by now. They could not explain it. They worked through the possibilities one by one. Volcanic rock ruled out. Producing enough phosphine that way would require resurfacing the entire planet far faster than anything we observe. Ordinary atmospheric chemistry ruled out by the thermodynamics. Reactions inside the acid cloud droplets implausible because concentrated sulfuric acid destroys phosphine rather than making it. Lightning, the very phenomenon Ksanfomality's instruments first found on Venus, argued against, because lightning chemistry tends to make oxidized gases, not this. Meteorites falling in too rare, too little. The most plausible lifeless explanation left standing was some exotic chemistry driven by sunlight on dust high in the clouds, and even that has never been confirmed in a laboratory under Venus-like conditions. As for life, the reviewers would not rule it out, but they were honest about why they doubted it. There is no obvious reason a living thing would spend enormous energy to make a gas and then simply let it drift away. On Earth, that act makes chemical sense. On Venus, it does not yet. So the deepest, most careful study we have arrives at the same place the Scorpion did. No known process satisfactorily explains the phosphine in the clouds of Venus. Either our understanding of that planet's chemistry is badly incomplete, or there is something there we have not accounted for. And the only way to truly know is to go back, to send instruments into those clouds and sample them directly. That has not happened. For now, the signal sits in the data, refusing to resolve into a clean yes or no. Step back and look at the shape of what we have. A man spends his life studying Venus. He builds instruments that fly there. He discovers, for real, that its clouds are full of lightning. And then, decades later, staring at the same grey photographs everyone else had set aside, he becomes convinced he can see something moving in the dirt of another world, and the establishment decides he has lost his way. Almost certainly, they are right about the Scorpion. It is almost certainly soil and noise, and the ghost shapes that sharpening tools pull out of fog. The machines that looked again said so, gently, on the balance of probability. But notice what the careful version of this story actually leaves you with. Not an answer. A set of open doors. We do not fully understand the chemistry of Venus. We have a gas in its clouds that, by everything we currently know, should not be there in the amount we see. We have a surface we have not touched in half a century, known to us only through the eyes of machines that died in minutes. And we have a question: could anything live in a place that brutal, that we keep deciding is absurd, and keep failing to actually close? The honest scientific posture here is not belief, and it is not dismissal. It is the patience to sit inside uncertainty without forcing it to break. To say what we know, mark clearly what we only suspect, and keep the door open precisely as wide as the evidence requires. No wider, no narrower. That is harder than it sounds. Easy answers are seductive life or no life, a clean yes or a clean no. The truth is that Venus has been offering us neither for 50 years and may go on offering us neither for 50 more. We built the machines. We dropped them through the acid clouds. We listened to the wind on a planet no human will ever walk, and we photographed the ground at our feet for 2 short hours before the heat took everything. We pointed our finest telescopes at that bright point in our evening sky and pulled a single, impossible whisper of a molecule out of the noise. And for all of it, for every instrument and every signal and every careful argued page, we are still standing here on a quiet evening, looking up at the second brightest light in the sky, unable to say for certain whether anything down there or up in those clouds is looking back.